Welcome to The Explainer. Today, we're putting on our detective hats to investigate a scientific mystery that completely took over the headlines just about a decade ago, the so-called pause in global warming.
In the early 2010s, you heard this everywhere, right? It was this super simple, really powerful idea that it created so much confusion, sparked all kinds of political debate, and even cast doubt on the very basics of climate science.
So what's the real story? Let's dive in. We're going to follow the clues and look at the evidence to see if we can finally crack the case of this supposed warming pause.
Okay, so our first piece of evidence, our first clue, really comes down to understanding what scientists were actually talking about when they used that word hiatus.
And that right there is the key. This was never, ever about a complete stop. It was about a slowdown in one very specific measurement, the temperature right at the planet's surface.
And wow, you can really see the difference here. The long-term trend was a pretty steady climb of about 0.12 degrees Celsius per decade. But during that 15-year hiatus period, boom, the rate appeared to drop by more than half. So yeah, you can see why this got everyone's attention.
And this right here, leads us to the biggest clue in the whole case. It's the clue that shows how this pause was born as much from statistics as it was from, actual physics. The year 1998 was a trap. So why a trap? Well, because 1998 was anything but a normal year. We had this monster El Niño event that just pumped a ton of heat from the ocean straight into the atmosphere, causing global surface temperatures to spike by about 0.2 degrees Celsius above the trend. It was a total outlier. And this is the heart of the issue, right here. If you start measuring from a pretty normal year, say 1996, the warming trend looks steep, just like you'd expect. But if you start that exact same trend line at the very peak of an unusually hot year like 1998, well, of course, the line that comes after it is going to look artificially flat. But, just like in any good detective story, the case didn't end there. In fact, new evidence started coming out that was about to change the entire picture.
So in 2015, a team of scientists went back to the drawing board. They went through all the raw data again. And this time they included measurements from a lot more places, especially the Arctic, which was warming super fast but didn't have many data points before. They also used better methods to line up temperature readings from ships and the more accurate ocean buoys.
And the result? It was an absolute bombshell. This paper, which people started calling the pause buster, pretty much doubled the calculated rate of warming during that period. Suddenly, the slowdown looked way, way smaller, almost identical to the rate from the second half of the 20th century. A huge piece of the pause just, poof, vanished.
Okay, so even with the better data, there was still that little bit of a slowdown. So where did the rest of the heat go? Well, the answer comes down to remembering that the surface of the Earth, the air that we measure, is just a teeny tiny fraction of the planet's total energy system. It's really just the tip of the iceberg.
Get this. Over 90%. That's how much of the excess heat trapped by greenhouse gases is being swallowed up by the world's oceans, not the air. So the climate system didn't stop warming at all. The surface just kind of took a little breather while the oceans were doing all the heavy lifting. So when scientists really dug in and broke it all down, the case was pretty much cracked. About half of that slight slowdown was caused by a natural ocean cycle, a La Niña-like pattern that was pulling more heat down into the deep ocean. Another quarter? That was because the sun was a bit less active during that period. And the rest was a mix of other factors, like a slower growth of methane in the atmosphere.
But here's the thing. Even with a really solid scientific explanation, the idea of a pause was just too powerful. It had already taken root, and it spawned a bunch of myths that were really hard to shake. You heard this one all the time. The argument was basically, hey, if your fancy climate models didn't see this pause coming, they must be totally broken, right? But in reality, when you actually look at large collections of climate models, you see these kinds of 10 or 15-year wiggles pop up constantly. They happen because of the natural kind of random chaos in the ocean and atmosphere. So the pause didn't prove the models were wrong. If anything, it showed they were doing a pretty good job of capturing the exact kind of natural variability we should expect to see.
Then there was this one, which was basically the myth of wishful thinking. The idea that maybe these natural slowdowns will just happen again and again and, well, bail us out. But the physics here is crystal clear. That natural variability, it's a two-way street. Sure, it can slow things down for a bit, but it can also speed them up. All the while, the total amount of heat being soaked up by the ocean just keeps going up and up and up.
Any future pause would just be temporary, and it would be starting from a baseline that's way, way hotter.
And then, just as this whole debate was at its peak, the planet itself delivered the final undeniable piece of evidence.
I mean, if the pause was a slowdown, what happened next was like a rocket launch. 2014 became the hottest year on record. Then 2015 didn't just beat it, it shattered it. Then 2016 did it again. The years that followed were just relentlessly hot, until 2023 came along and didn't just break the record, it completely obliterated everything that came before it. The whole narrative that warming had stopped was just toast.
And this is why this whole story matters so much. The illusion of a pause wasn't just some interesting scientific debate. It actually provided political cover to delay climate change, confusing the public and locking in higher costs and way bigger risks for all of us.
So the real takeaway from this whole detective story is simple. We've got to learn how to tell the difference between the long-term signal of climate change and the short-term noise of all those natural ups and downs. Because at the end of the day, the next time someone brings up the pause, the right question isn't whether the surface cooled off for a few years. It's whether we're getting distracted by a 10-year wiggle, or if we're focused on the 100-year bill that continues to grow. Because the physics and the oceans, they really don't care about our favorite start year.